Hello everyone, welcome to this lecture series on Introduction to Machine Learning. So in the last session we discussed about K-means clustering, the theory part of it, and in today's session we will try to look at Python implementation of K-means clustering in using Jupyter notebooks. So here we are at the Jupyter notebook, right? Let's just revise or recollect what K-means clustering is all about. So as we have studied in the last session, K-means clustering is an unsupervised learning algorithm that tries to cluster data based on their similarity. Unsupervised learning means that there is no outcome to be predicted, and the algorithm just tries to find patterns in the data. Okay, so it is an unsupervised learning algorithm. That means there is no target variable. So there is no y, there is no output that we want to predict, right? So we have to keep this in mind. There is no sample examples. Okay, it is not supervised, it is unsupervised. So there are no examples. Okay, so there will not be any training and testing split of the data, because there are no examples from which we want to learn and then we want to predict. So it is a different case. It's an unsupervised, where we just want to find patterns and similarities, and based on those similarities in the data we want to divide or group our data into some clusters. Okay, so let's look at the steps. So in K-means clustering, we have to specify the number of clusters we want the data to be grouped into. The algorithm randomly assigns each observation to a cluster and finds the centroid of each cluster, right? And then the algorithm iterates these below through two steps. Okay, so reassign data points to the cluster whose centroid is closest. Calculate the new centroid for each cluster. So basically, it starts with random distribution of clusters in the data, right? First we define how many clusters we want. Suppose 4, 5, 3, 2, or whatever, right? Then we randomly assign those clusters. Then we assign all the points to the nearest cluster center. Okay, so which for every data point, whichever centroid or cluster center is nearest, we assign that particular data point to that particular cluster. And once all the data points have been assigned to any of the clusters, we uh, uh, mm, again recalculate the cluster centers or the cluster centroids, right? And once we recalculate the cluster centroids, we again go through all the data points, assigning them to the nearest centroid, and we keep repeating until there are no more mm, reassigning possible. Okay, so until the we keep doing the same thing of for calculating the cluster centroids, assigning all the data points of the nearest centroid, unless until the points stop changing. Okay, so these two steps are repeated till the within cluster variation cannot be reduced any further. So within cluster variation cannot be reduced further means that the points does not belong to the same cluster, right? And even like by furthermore repeating the same steps, the clusters are not changing. The data points who are assigned to the cluster, they are not changing. They're not moving between the clusters. Okay, the within cluster variation is calculated as the sum of Euclidean distance between the data points and their respective cluster centroids. So this within cluster variation is the distance between data points and the centroid of the cluster. Okay, so let's start the implementation using Python, right? So we will start with importing all the important libraries. So we are importing Seaborn as SNS, matplotlib.pyplot as PLT, and we are doing matplotlib inline, which allows us to see our graphs in the output cell. Right. So one interesting thing that we're doing in this particular example, in this particular implementation of K-means, is that we are creating our own data. Okay, so we are generating our own random clusters using a method or a call function called make blobs. Okay, so make blobs function allows you to create blobs of data, right? So you can create your own clusters of randomly generated data using this particular function. Okay, so it is the part of sklearn.datasets library. There's a function called make blobs which we can import, right? And I can create my data using this. So make blobs, I want to have 200 data points. Like n samples means how many data points you want, n features means how many features you want, or how many columns you want, right? So I want two features only. And how center means how many cluster centers you want. I want four cluster centers. And what should be the cluster standard deviation? I'm putting it at 1.8, right? And what should be the random state? It is 101. You should also keep the same state if you want to get the same result as mine, right? So this will generate a data like this. So what this thing did, it generated 200 samples, 200 data points, 200 rows of data with two columns with two features which are centered around four centers, right? So it randomly generated um, so 200 data points which are in forms of clusters, four clusters as we have defined here, right? So this is a randomly generated data set. It looks like this. So x value is this, y value is this, x is this, y is this. Why two dimensional? Because it we are doing this for our learning purpose, and so two dimensions, like two features, are very easy to visualize. That's why we have generated only two features. Now let's go ahead and look at the next step. Now next step is to visualize this data. Right now I want to visualize this data. So I'll do a scatter plot. So I'll do data 0 contains my data points, right? As we have seen here. Data 0 contains xy values of my data set, which we have created. So I want to plot data 0, all the rows and the first column, with data 0, all the rows, second column, right? And the color I want to be data 1. Data 1 contains the cluster centers. Okay, let me just show you, right? So if I go to data 1, see, it is showing. So data 1 contains the information about which cluster each data point belongs to. So like there are four clusters that we have defined. So like 0, 1, 2, 3 are the three clusters, are the four clusters that my data point may belong to. So data 1 contains information about which cluster each data point belongs to. So like the first point belongs to third cluster, second point belongs to second cluster, third point belongs to the cluster 0, right? So here the color coding scheme should is the according to the cluster, and the C map is rainbow. So this is what my randomly generated data looks like. This is my data which I have generated, right? Randomly generated data, it looks like this. There are like four clear clusters. You can also keep the value of clusters to be 2, so that you get like one big cluster here and one cluster here. Let's just try that. Okay, because we have tried for four centers, we will try that while doing k-means. Now next part comes as creating clusters using k-means, right? So we will import from sklearn.cluster, we will import k-means. I would highly recommend you guys to go through the sklearn dot cluster dot k-means documentation. I have kept it open for you. Just Google search for K means sklearn, and you can directly land on this page. There are like multiple parameters that it takes. There are all have been defined over here. Okay, you please go through it, and you'll be able to make it work. Okay, so we will import k-means from sklearn.cluster .cluster, right? And I need to initialize. We need to initialize k-means in our to be used in our program, right? So I'm initializing k-means as k-means, right? K-means, this is the variable I'm creating for k-means algorithm, and I'm keeping the clusters to be 4 because I know there has to be 4 clusters, because we have generated our data ourselves, right, with 4 clusters. Now I will do k-means dot fit on data 0. Data 0 is what? Data 0 is x is my is my data point. Okay, both first variable and the second variable, like two features. This is my data 0. Data 0 is this is my data, both x and y columns, right? So I want to fit my data. I want to fit k-means on this particular data, which is this data 0, right? Now it shows that the k-means algorithm has been fitted into it. And if I want to print what are the cluster centers as per the k-means algorithm, it is this. So these are the 4 cluster centers which k-means algorithm has designed. And if I do data 1, these are the cluster of the my data belongs to by definition. Okay, and if I look at k-means labels, so these are the labels, or these are the data point these are the clusters which k-means have assigned to my data, right? So these are the actual cluster values, and these are the clusters my algorithm has assigned them to, right? Now we want to plot them against each other to see like how my k-means algorithm are performing, and how is my data distributed originally, right? So I'll use subplots f axis1 and axis2 plt dot subplots. So I want one row with two columns. I want to share them in the y-axis. The figure size should be 10 by 6, right? And axis one title should be k-means. One is for the k-means, and I will plot data 0, all the rows, the first column, all the rows, data 0, all the rows, and the first column, right? Second column, right? And the color scheme should be k-means label. So the k-means label means what is the cluster group, or what is the cluster that my algorithm has assigned all the data points. CMAP is rainbow. And on the graph 2, axis 2, I will plot my original data, like what was the data that I generated, right? So this is uh, what it looks like. Let me just zoom out a bit, right? So this on the left hand side, the graph is what the k-means algorithm has assigned the clusters, and on the right hand side we have the original data distribution. So we can see that like it is very much same, almost like for this particular cluster it is exactly same. But we can see on this overlapping part, as we see here, like these all some of these overlapping points belong to this blue cluster, which k-means have misinterpreted, which it has assigned to some other cluster. So only in this overlapping part we are having some issues, but like it looks very perfect. Okay, now let's just try to make two clusters, right? So I want to do two clusters. Now what changes it will look, you can see, right? So all this remains same. Now let me fit that fit this down. So if I do two clusters, my k-means algorithm will, of course, as we predicted, it will make all of these into one cluster, and this one remains the same. So if I do two clusters, then I get this output, and this is the original output because we have designed four clusters. Okay, so both the way can be used. And if we do three clusters, then let's see uh, what changes do we have to see. If I do three clusters, so this is what K-means algorithm is giving me. So one this big blue cluster, one green cluster, one red cluster. So my algorithm has combined these two clusters together. If we do three clusters, right? So this way you can do multiple hit and trials and whatever. And based on the elbow method, we will see in just in a few seconds, few minutes, how to come about or how to decide on a value of k, like how many clusters we should use, right? So this is one way of doing it. Next, we look at one more implementation of k-means clustering using Python on Jupyter notebooks on an actual data set, right? We import all the required libraries like NumPy, Matplotlib, and Pandas, and the data set that we are using is in form of a CSV file of mall customers. Let me just show you that file. Let me just share my screen with you. Okay, yeah. So now you can see the Excel file. So this is the Excel file which will work as our data set. So it is data about some customers in a mall, right? And we have the first column is the customer ID. Second is the gender. Sorry for this spelling mistake, not genre. Then we have age, income, and spending score, right? So basically, some mall is keeping track of all the customers that are coming to the mall and buying stuff from the mall, and they are recording their ages, their annual income, and they're creating some spending score, right? So here we do not have any particular y variable or the target variable that we want to predict in general, but there are all of them are kind of features. So using all of these features, we need to figure out, we want to classify, or we want to put our my customers into different groups. Okay, based on like mainly annual income and spending score. So because we want to visualize our data, so we will be taking into account only the annual income and the spending score, these two columns, these two features. And we can also take into account the gender and the age, which is maybe left out to for you to work on. But for this particular implementation, we'll be just looking at annual income and spending scores, which is the column number 3 and 4. And anyways, like the customer ID is just kind of a number or a serial number. It does not count as a feature. It is not playing any role in defining which cluster any customer should fall. So we can completely ignore this customer ID as it is not a feature or an attribute, right? Let's go back to our implementation, right? So in the dataset variable, we are reading this CSV using the pandas library mol.csv, and in the x variable, we are storing the values from the third and the fourth column of the data set, right? ILOC means give me the values at the located at the index, uh, where like all the rows and third and the fourth column. So this is what my x looks like, right? Only the salary in $1,000 and the spending amount, spending index, right? Spending score, sorry. So spending score is something like which depends on how much money you spend on in the mall monthly or periodically, and based on that they give you a score. If you spend much, you get a high score. If you spend less, you get a low score. So based on this based on their salary in $1,000 and their spending score, we want to group customers together, right? So now let's look at our data set. So my data set looks like this, but my like it has all the five columns, but my x variable or on which I want to fit my clustering algorithm looks like this. It has only two columns. So now let's just look at the elbow method to find the optimal number of clusters, right? So from sklearn.cluster, let's import k-means, and wcss stands for within cluster sum of squares, because we want to look at we want to compare the within cluster sum of squared error, or within cluster the distances of all the data points from the cluster center to center. So we have created an empty list which will store all the distances or all the sum of squared errors, right? So now I want to run a for loop from like 1 to 10, right? 1 to 10 as in I want to keep the clusters to be 1 to 10, 1 2 3 4 5 6 7 8 9 and 10. For all these k values, I want to fit k-means algorithm, and for all those k values I want to check what is the trend of within cluster sum of squares, right? So for all of these I will define k-means algorithm, and the and clusters will be equal to I. In it I am keeping is at it as k-means plus plus. So it means how to initialize my algorithm, right? Remember we studied like there is a random distribution of the cluster centers for initiating the problem, or for initiating k-means, right? So there are some problems which k-means face where if we start with random initialization, right? So at times if you start randomly, if you uh, place a cluster center very far from the data points, so there will be no data points which will be associated to that particular cluster. So to avoid that, to have a smart assigning of clusters, we use this particular variable, or we use this particular term called k-means plus plus, which is a kind of smart initialization of clusters, and the random state that we're using is 42, right? You can also look at k-means plus plus algorithm by using this particular link. I'll share this. This is on Geeks of Geeks, so you can also read about this k-means plus plus on Wikipedia, right? Next, I will fit k-means dot fit on x. So like for particular value of 1, fit that particular k-means on our x value. Then wcss dot append, because it's an empty list, dot append k-means inertia. Now k-means inertia is like by default attribute which gives me the value of within cluster sum of squares. Okay, so this particular term inertia gives me the sum of squared distances of all the data points from its particular cluster. Okay, so basically it is giving me within cluster sum of squares of the k-means which we have defined over here. Right, now I want to plot for 1 to 10 what is I want to for each of the cluster what is the wcss, and like I have given the title as the elbow method, number of clusters x label, and the y label is wcss. Now this my graph looks like this. So for the number of clusters, as the number of clusters increase, my within cluster sum of square decreases. So I can see over here like at this particular value of maybe 5, I am getting the most abrupt change. This is the elbow of this particular graph. That's why it is called a elbow method. Right, now we will now we know this is the optimum value for my clusters, right? If you go more than this, then it is not, it is of no means, right? Because you want to classify, you want to make a cluster or a group your customers together, right? So 5 seems like an optimum value, right? So I now again train a model, training the k-means model on the data set. Now I know the number of clusters. So I will again do k-means and use this library. I want 5 clusters. The initialization should be in it should be k-means plus plus random state. I'm keeping at 42, and I want to like key in a separate variable. I am doing k-means dot fit and predict. Right. So basically, it is fitting the k-means clustering algorithm on my x feature vector, and it is also making a prediction. Okay, based on the k-means, this particular data point should belong to which particular cluster. Right. So if I print y k-means, it is giving me the it is giving me the cluster ID. So there will be like 0, 1, 2, 4, right? 0, 1, 2, 3, 4, because I want 5 clusters. So it is like the first data point belongs to third cluster, the second data point belongs to the 0th cluster, the third data point belongs to the third cluster, like this. So it will give you which cluster each data point should belong to, right? And these are the cluster centers. So k-means dot cluster centers give me the cluster centers, right? Now how to visualize the clusters. So there is one quick trick over here. So if I do like this, suppose you remember what is x. So x is are my 2 columns. So this is what my x looks like, right? X. So this is the value is it's a feature vector. X is a feature vector, right? It contains values about salary in $1,000 and uh, spending score. So if I want to fetch uh, if I want to fetch only only those data points from X where the Y means is 0, I can do like this. So from X, give where Y k means is 0, give me the 0th column, right? So this means that you give me only those values where yk means is 0. Yk means is 0 means like give me only those rows, give me only those data points which belong to the 0th cluster from the x vector. Okay, so from the x vector, give me only the salary because I'm taking the 0th column. So give me only the salary of the people who belong to the 0th cluster. Okay, this will only these are the people who belong to the 0th cluster, and these are the salaries. So these are the salary of the people who belong to the 0th cluster, right? So now let's visualize them. I think so. Now, since we know the number of clusters is 5, I want to visualize my results. So this is how we want to visualize, right? This is what my final visualization should look like. So how we can do this is very simple. So I want to make a scatter plot, and a scatter plot should be about like something x versus something y, right? So my x column, so my x axis is going to be the annual income, and y axis is going to the expanding score. So for X, for the how can I get the age? So age is the the spend the average the annual income is the in the X vector is the Y column. That means in the X vector it is the 0th column, right? So in the X vector in the 0th column I will get the salary, right? And the first for where y means is equal to 0 means it will give me only the customers for for that belong to the 0th cluster. Okay, so this thing is giving me the salary of all the customers who belong to the 0th cluster. This thing is giving me the salary of all the spending score, because the y here the column I'm taking the first column. So this thing gives me the spending score of all the customers who belong to the 0th cluster, and S means the size for the marker. It is in 100 points, and for distinction I'm taking it is to be a red color. The color is cluster 1. So similarly, by changing just this particular value yk means value, I can get the value of all the customers belonging to the different groups, right? So for the cluster 2 I'm giving the blue color, for cluster 3 I'm giving red color, green color. For cluster 4 I'm giving cyan color, and for cluster 5 I'm giving magenta. And at last I'm plotting all the cluster mean centers, right? So there are 5 cluster centers because we have derived that 5 is the best case most optimal number of clusters. So cluster centers, give me all the cluster centers which are 5, only the 0th column. That means give me the salary. And cluster centers, all the rows 1 means give me the spending score. S is 300. That means the marker pointer size is bigger than the clusters, and the color is yellow, right? And after giving proper labels, we get the graph like this. So these are the 5 clusters, right? So red, green, blue, pink, and this sky blue color gives me the 5 clusters, and the bigger yellow circles give the circle cluster centroids. Okay, so these are my data distribution, or this is a distribution of my cost customers. So if I want to club my customers into groups, this is the best 5 groups in which I can put them. So on the left hand side, I have the customers which have low income and their expenditure is also low because based on their spending score. And on the rightmost, on the top right, we have these green customers who have higher annual income, and their spending score is also high. So and these are some average income guys who are who have moderate income, and their spending score is also moderate. So like based on proper, so I want to put these schemes, and we want to pitch those strategies, those offers to these particular pink people belonging to the pink group who have higher income, but like probably they're not spending much. Okay, so based on, and these are the red ones are like they have high spending scores, but their no income is not that uh, high. So these people can be like people like a young or bachelors who like freshers who just got their jobs, and they are like they went to like big cities. I'm taking an example from the Indian perspective. So they started living in on their own, and they have they're earning low, but they can spend much because they just have to. They are enjoying their life, and they have to spend their money on their own. These green ones can be like the rich, proper rich corporate people who have high income and they spend highly. And these the pink ones can be the aged government officials who are earning high, but they have moderate expenditures. Okay, so they do not spend lavishly on like movies, and they do not buy expensive clothes in the mall, right? So this can be one of the explanation of such a uh, distribution of customers of a mall, right? So like this we can use k-means to make meaningful to meaningful clusters and put data into similar groups, right, based on some underlying similarities, which we can find some explanation also, like we did in this case. So thanks a lot for your time. This is what I had to discuss with respect to KMeans implementation. Like all the best to you and stay safe.